right, I think we'll get started here. I still see a whole bunch of people funneling in, but we've got a lot to get through, so I think it would be best if we get going. Hopefully everybody can get caught up. That's okay, we're just gonna do a little bit of recap stuff up front here. So hopefully most of you joined for part one. If not, we'll do a little bit of overview to catch everybody up on what we talked about last week. So this is part two, and what we're gonna focus on, so if you remember in the previous session, we went through an overview of analytics, kind of end to end, and I promised we would double back and go a little bit deeper on two different halves of modern cloud data architecture. So this session is going to take us all the way from the modern data sources that we work with and the way that we move things from left to right, all the way kind of before analytics, like data warehousing almost. So kind of in that fuzzy zone between getting all the data extracted and transformed and landed where we need it to be. And then in part two, we're going to take it from kind of warehouse forward through to advanced analytics and data science. So we're halfway there. Thanks for joining again, 2 weeks in a row. My name is Chris. For those of you that weren't here last week, I have a pretty awesome job at NewComp. I get to work with all of our data science and advanced analytics practice projects across North America, which is pretty awesome. We do a lot of really cool things, both from taking legacy architectures and deployments and modernizing them, as well as introducing organizations who have never done analytics and getting them started. So everything along the analytics maturity curve, from basic to super advanced, I get to see all those projects, which is really awesome. My background is probably much like many of yours. It's not like I grew up doing data science. This is somewhat of a new paradigm, but the experience I did have allowed me to make the change that I'm trying to hope to inspire you to make, both for yourselves personally and for your organization. So, I grew up building these. We're going to talk about generation one architectures. Well, I was there, and I'm sure a bunch of you were there too. And I've seen the evolution and all the baby steps along the way. So, like I said last time, it's as much as me telling the story of how to go from mid 2000s emergence of BI and analytics to making sure that you're ready for the next 10 or 15 years of where this industry is going. Here's a little breakdown of what we're going to do today. A little bit of recap from last time. I'm just going to do it in the context, less generally this time, and more specifically in the context of modern data integration and acquisition. We're going to talk a lot about data, because that really is what we're trying to tackle here. Data used to be a lot simpler, at least the data that our users were interested in. It was rows and columns. It usually lived in SAP or in JDE or in one of our Dynamics, one of our ERPs, or in some transactional system. Data lives everywhere now, everywhere, and it's in all sorts of formats. And so we're going to talk about kind of type by type, source by source, how to go get it, what the tools we use are, what are the best practices, what are the organizations who are best at doing this, what are they doing these days? And so hopefully you can borrow some ideas from those who have tested it out and maybe failed and then tried something else and found that it worked. So I'm going to give you some ideas to steal. That's what I hope for. Orchestration, kind of a niche word for what we do, but really this is just making sure that everything that runs, all these pipelines that we've built and all the extractors, that all the dependencies, that it's all organized. And that all used to be kind of rolled into one tool, like an ETL platform, but now it's really decoupled. So we're going to have all sorts of little engines running that are moving data from A to B, and then we need something watching over them all, right? As kind of a site coordinator that's saying, okay, you go, then you go, then you go, and if this fails, then go back and run something else and notify people. So I'm going to show you how modern analytics and data pipelines are orchestrated and scheduled and governed and that sort of thing. Then we're going to talk about storage, because ultimately we have a bunch of data, and when I say that, I mean like massive amounts of data in all sorts of formats, in all sorts of quality states. And so we need a new way of organizing that. We talked a little bit about data lakes last time. I'm going to kind of strip away the data lake label, and we're just going to talk about data and how we store it, and the different ways that is done these days. based on the requirement. So I don't want to just throw a bunch of terms at you. I want to say, if you're going to use it for A, then store data in format X, okay? Now we're going to talk about governance. This is always a fun way to end because it's always this pipe dream that everybody has about having perfect governance. There's for sure mixed opinions on the value of formal data governance. Don't shoot me. That I'm just repeating what's being said out there. I think this is a moving target. Remember, data isn't static; it's always changing, and so governance is never done. Right? That's how I would characterize it. We're never done with our data catalog or with stewardship on data, and it's really tough to formalize this. I think universities and hospitals and government entities that are used to governing data in a very, very strict way, and maybe it falls into like records and information management, that's a tough way to manage modern data. And so I'm going to share some ideas with you. Okay, so that's where we're going to go. If you can plug your ears, if I'll take 30 seconds just for those who didn't get a chance to join the first time. Who is NewComp? NewComp's been doing analytics for a long time before it was cool. I mean, the best part about doing this for 20 plus years is that we've got a whole, just as data people, we've got a whole pile of data of what works and what doesn't work. And so I think we're in the best position to advise on how to get from how it used to be done to how it has to be done going forward, just because those are the projects we're taking on right now. Our modernization projects, our migrations from that data warehouse that's been running for 10 years or 15 years, moving that to the cloud, or taking big long ETL processes that take hours to run overnight and modularizing those so that they're way more resilient and robust and can handle the data of today. So I think we're in a pretty awesome spot. We obviously have a big broad consulting team. So the way that we work normally, maybe this is a good way to talk about it, is just how you might work with us all the way along the journey. So if you need to inspire folks at your organization, so through some kind of roadmap or something a little more strategic that says, here's where we are today, here's where we aim to get to, here's the steps to get there. That's the sort of thing that I participate in. It would be awesome to work with you on that. If you already kind of know what you would like to do and you've got a fuzzy picture of where you're aiming for, then maybe we can help you do like rapid proof of concepts. So testing ideas, some of the stuff that we talked about last time and this time, help you test some of those things out. We also have specialization. So not just with our vendor partners that are on the screen right there, which I'll talk about in a second, but if you need someone with really heavy math skills to do complex optimization on some facility or process that you have, in operations, then we probably have that specialization. We've got a whole broad team of engineers and math majors and computer science folks, or people that came from retail or with a physics background. So ask away. I think we've probably got someone buried somewhere in NewComp that can help if you need some sort of specialization. I think the partners here, and I kind of explained this last time, we try to pick the ones, we've got to pick a horse in every race, right? We can't possibly have strategic partnerships with every technology vendor out there. There's hundreds. So what we do is we pick the ones that A, we believe in just product roadmap wise, and they've got the right organizational structure, and B, ones that work in Canada. I'm going to be honest, ones that aren't built for these a big US bank. I think that doesn't work in this market. And so a good portion of our business is in Canada, or NewComp's head office is in Toronto. I'm here in Calgary. Those are very different markets than New York and Chicago, right? So so that's why we've doubled down on a lot of these technology partners. The way that we chop up our practices, this is what we call our DNA, because it really does make up what NewComp is. Some of this is have been practices at NewComp for a long time, something like BI and data visualization, or our financial performance management practice, which is really about using modern technology to do things like forecasting and budgeting. We've got more advanced analytics practices, our AI and machine learning and open source, which I'm very proud to be a part of. And then wrapped all around that is data management. We're going to talk a ton about that today. So wherever you are, whatever your focus is kind of in the data world, we for sure have a whole practice built around it. So I'm going to offer it a bunch of times today. Send me a note and just ask questions, and I'll share whatever I can with you. That's the whole point here. Okay, real quick overview, because I know there's at least 10 or 15% of the hundreds of people who weren't able to attend the first one. So I'm just going to recap really quickly in a couple of minutes how we got to where we are in the cloud, because I could do modern analytics architecture in general as a session, but this one's very specific to the cloud. So I think it's important to talk about why we got here. In the 90s, maybe some of you were there, maybe you weren't. This is before my time, but really the genesis of data warehousing. There was a book written in 1996, I think, called The Data Warehouse Toolkit by a guy named Ralph Kimball. And this kind of sparked there's a couple of different methodologies to data warehousing, but this really sparked mainstream data warehousing. Tools like Cognos and Business Objects and Hyperion, I think. Tools back then were pretty basic. But they still required a technologist to develop those reports. So it came to a BI developer with requirements. They built a report and queries, and then they handed it to a non-technical user to just run and run and run, right? Maybe enter some parameters. That only lasted for so long because that person really was a bottleneck. And so we needed to decentralize that a bit. And so we said, okay, we're going to allow some of our non-technical users to drag and drop and build their own reports and visualizations. They really know what they're looking for. So we're going to build the data models for them, and then they're going to do their own dragging and dropping. And that was good. In the meantime, the whole world was exploding with data, right? So we had data coming off of sensors and the web, just as in general, web applications, phones and apps generating data. The world was generating so much data that those data warehouses I was just talking about couldn't handle it anymore. Too much data, too varied of data. It was not clean anymore. We tried to jam that into data warehouses. I saw those projects. It didn't work. So we needed new structures to handle all that data. And so some of the big cloud platforms, the Facebooks and Yahoos, who were pioneering some of this stuff in the early 2010s, started to build technology to manage that data and do massive computing operations on it. Eventually, they realized that they built all these big data centers and services, not just for themselves, but that they could open it up to the public and offer it as a service. And so because of the economy of scale of those data centers and massive fields around the world and interconnected internet backbones, they had built an infrastructure that they could still give to you and me for a small fee and still make massive profits. You see the profits of those companies spiked, right? Amazon turned from a retail store into a cloud computing organization, and they turned what was their biggest expense into their biggest profit center. And I think nobody is better than Amazon at doing that. So pretty amazing. We benefited from this. These services that used to take entire data centers to do, now you and I can just turn on with the click of a button. Costs us 11 cents to run some sort of analytical query, and then we can shut it off again. So pretty amazing. And the cloud is really just that. I don't want to pump it up any more than it really is. It is somebody else's computer and somebody else's services that we are using as a service. And there's trade-offs, right? So we're paying a little bit of a higher price, perhaps, for a service that maybe if we bought that license 10 years ago, we just pay a renewal on it going forward. It might cost us a little more to use that now as a service, but we're not doing upgrades ourselves. We don't need a full-time administrator. Somebody else is watching the network and making sure that it has 99.99% uptime. There's a lot of trade-offs for that as well. We really, I think most of our organizations wanted to get out of the infrastructure business, and we're a bank or we're a retail company, we're not in the IT business, and so you can take a lot of those things and just use them as a service. So the cloud is nothing mythical. We use it in our daily lives. I talked about this last time. Netflix, we use Google, email, at NewComp. All of those are software as a service. All of those are the cloud. And so it's not something scary. The corporate world is way slower to adopt the cloud than most humans have been, which is really interesting. And when I talk about the cloud, for the purposes of this, what I really mean is the public cloud. So those ones that are hosted by Google, Microsoft, Amazon, Salesforce, IBM, Alibaba, the big cloud providers. There are private clouds out there. I think I mentioned this last time. The ones we see are generally buried in very sensitive organizations, so defense departments and investment banks, and and maybe they keep some of their stuff on their private cloud, and then they use some non-sensitive data up in the public cloud, and they can join those two things together, and we call that the hybrid cloud. So this combined pool of resources, both publicly and privately. Okay. All right, that's my recap. We're going to go through this architecture really quickly like we did last time, but this time I'm going to start going really deep on each of these components, okay? So we talked about this last time in that the role of us as data workers, so put on the data engineering hat for a second and just assume that this is our role. Our job's to move data from the left-hand side of this diagram, I think the camera's reversed, left side to right side, and get data from wherever it lives and get it to users who need it most, okay? So let's just assume that that is our job. And really, we literally think about this, I'll use an analogy, but we think about this as like a logistics company, right? We need services to lift and move data constantly from where it is. Maybe that's in big bulk loads, like a big shipping container on a giant ship. Maybe sometimes that's very precision move. Anytime there's a new box on that pile, I go and grab the forklift and move it into my pile. So we need a bunch of different ways to move data from its source to our landing zone. When we land it, we generally land it in a raw format. We're not opening the box and taking stuff out and putting it in. And we're just moving things exactly like they were in source into our landing zone. And then maybe we need a way to package it up. So this is where we start taking things from multiple source raw boxes and combining them for one customer, right? So let's say they ask for a little bit of this and a little bit of this. We put that into one package and we get it to the end user, and that's really our job. I skipped over the data governance and data science stuff at the bottom last time. We're going to talk about that a little bit this time. We always need a way to ensure quality and make sure that what we asked for from the source is indeed what landed in our storage zone. So we've got a lot of different ways that we govern this process, this supply chain from start to finish for data, and that's what we really refer to as governance. Let's strip away the analogy for a second and just start standardizing on some terms. So we're talking about ingestion and replication of data, and that is our pipeline. So moving data from source to landing zone. Once it's in our landing zone, we do refine it. So we take it from really raw data, then maybe we rename some columns, for example, or we strip away some stuff that we don't need. And then we might build a very curated data set for our users, right? And we might expose those as a data mart, for example. These are all terms that we'll go over in a little bit. And then we've got all these supporting services on that data. So whether it's profiling and ensuring quality and completeness, or maybe we're enhancing that data. Users are taking raw data in there, maybe they're making predictions or forecasts, or clustering things together, looking for patterns, and then writing back to that data source as well. So we've got this constant kind of fluid motion of data, both being consumed and being enhanced and then being monitored and governed, okay? So that's the architecture. Just take a mental snapshot of that. We'll trim it down a little bit like we did last time. We're gonna go way deeper into the kinds of zones and types of ingestion that we're doing, and we'll end today kind of at that data warehouse tier. So that's where we'll pick it up next Tuesday. We'll talk way more about what data warehouses are now versus what they used to be, and then what we can do with that data from a consumption perspective, okay? So terminology, in case you didn't get it last time, I'm gonna go through it really quickly. ETL and ELT, those letters stand for extract, transform, and load, and the order of that is important. These are the functions that move data from one place to another in this architecture. Data lake is really just a raw landing zone for data. This is our storage tier. You can think of it like a file system for data, and a data warehouse, which we'll touch on a little bit. Think of this as an analytics engine. So this is a computing workhorse that goes and somebody asks it a question, it says, okay, I'm going to translate that into some language, go after some files, join them together, and give back a result. So the warehouse is really the workhorse in this architecture, okay? All right, new stuff. Ready? Get out your pencils. This is all new from last time, okay? We tend to wrap, I have to find ways to give you terminology to go away and do some research. So I'll give you a role to think about, which is data engineering. And data engineering really is the result. I put in the notes there that I think it's really this combined what used to be business intelligence and a little bit of data warehousing background, and then certainly some software engineering skills. And if you think of that Venn diagram, most of you probably already have some sort of BI background or data warehousing knowledge, at least of databases, maybe not the software engineering side. Luckily, the cloud has made that a lot easier. 3 or 4 years ago, you were doing a lot of scripting if you wanted to like build a pipeline. Now it's been abstracted. I'll show you the interfaces in a little bit, but it looks like another, it looks like PowerPoint, right? Like it's very drag and drop. A lot of the software engineering has been abstracted and is continuing to be every year. What used to be a complex tool is now combined with something else and put into a nice friendly interface. So this is changing all the time. And really your goal, like we talked about, is to take the appropriate data and move it from A to B, working with users. And so as I try and give you this profile of a data engineer, I think it's important that it's not some unicorn. You don't go to school, at least you don't have to go to school to be a data engineer. Those skills that are on the left-hand side of this diagram, you probably have a bunch of already. And so it's just a matter maybe of learning a couple of concepts and maybe getting trained up in 1 or 2 interfaces, and then you're ready to go. So this is by no means something that is unattainable. And I think everybody should achieve to have these skills to some degree or another. Why do we even do data engineering? It touches everything we're going to talk about today. So that's building the pipelines to move data from A to B. It is deciding whether that data source should be real-time streaming captured data, or whether it'll be okay just to schedule and extract from that source, and what happens if it fails. When we do land that data as a data engineer, most of the time I'm maybe not responsible, but I should be an advisor on privacy and quality. So I'm maybe taking requirements for desensitizing personally identifiable information and applying some sort of data masking to it, right? I'm enforcing quality in those subsequent zones. So when we land raw data, maybe that stays in my raw zone, but my job as a data engineer, if that data is going to move into more of a curated zone, now I'm applying rules to it, right? So I think that role as a data engineer is really cool. It touches all the components that we're going to go through today and a bunch of what we're going to go through next Tuesday as well. Let's talk about the kind of data that we deal with today. This is probably what almost everybody is familiar with right now, something called structured data. And when we talk about structured data, we're really talking rows and columns, right? This could be in an Excel spreadsheet. This is data that is very common, things like transactions, like retail transactions, or our financials, right? Account major and minor codes by month or by day, or employee and HR records, something that's has a title and has a bunch of rows, okay? But that's not all the data today. It's certainly still a bunch of it. When we talk about, I'll put a quarter in the swear jar because I'll say big data. But when we talk about big data, we're generally not talking about structured data in most cases. What we are talking about is the next 2 items, which is, so this is what we call unstructured data. No format from what a human can see. This is like a picture or a video or recordings of calls in our call centers. Most forms of documents like PDFs generally don't have a structure. And so this is raw, very raw data that you might think, well, what kind of analysis can I do on a video? But we see it done all the time. We might train a model to recognize a safe condition on a well site for an oil and gas company, right? And so we use hours and hours of video to say this is a safe condition. Somebody's standing far enough apart from this piece of equipment. The truck is parked in a certain area. They're wearing their protective gear, and that model can be trained to recognize in a streaming video when there's an unsafe condition. So images, pictures, audio, all of it has analytical untapped potential that we go after now in modern analytics. Semi-structured data, this is now sort of readable by you and I, but doesn't really fall into rows and columns. Something like weather data, the data that sits behind eBay and Amazon listings, something with very variable attributes across all the rows is perfect for this kind of structure. Most of the time we're going after things like weather data. Any IoT, like connected device data often comes in JSON or XML format off of sensors and vehicles and that sort of thing. And then we've got metadata, so data about our data. And we'll talk about this when we get to the portion on data governance. Now, what does that mean? That means we've got a lot of different data sources to go after. And believe it or not, this isn't a looping animation. This is some of the data sources that we deal with on a daily basis. And there are hundreds, right? Hundreds. And these are APIs that are exposed to us as data engineers to go get data from, right? The good news is that there's a lot of pre-built connectors for us, and we don't have to fiddle around with third-party drivers and stuff. A lot of the platforms have these data source connectors already built in, but man, there's a lot these days, hundreds and hundreds to consider. And this is where I'm going to run my first question. Now that we've kind of agreed, my mouse fell asleep. I'm going to run a little poll just to see how people feel about untapped data in your organization. So now that we've talked about the different types of data, how many of you feel like there's untapped potential in non-structured, semi-structured, or unstructured data in your organization? And this is interesting because I think I can't think of a project that we have touched in the last 3 or 4 years where we didn't discover that there was some sort of untapped potential. All right, there's almost everybody has voted. I think I can share this with everybody. I'll share it with you. There you go, so you can see the results. For sure, there is untapped value. And sometimes it's just a matter of making a business case for going after it. Sometimes it just takes a project or program to spin up. Somebody has to champion going after that data. I think we can all agree that there's a lot of work we still need to do to go augment the transactional data that we're probably reporting on now, and using some of that semi and unstructured data to do so. All right, cool. Thanks for voting. We got one more a little bit. We spend a lot of time in this world, and so because of all those data sources, a whole bunch of the time before we even get to some fancy machine learning model or a new dashboard, a lot of the time the work is just done joining those tables together, making sure we get the level of granularity right, cleaning up columns, making sure that it's an automated pull, or that streaming data is working properly, that our triggers are working. And we need those tools. So the tools to lift back and forth, things like Azure Data Factory or AWS Glue, things like Databricks, or pure ELT tools like Fivetran and Matillion. We use all those tools to do the moving from A to B, and a combination of those tools to do it. But we spend a lot of time in that zone. And I talk about a few of those tools. Man, there's a lot to choose from. And I think this is maybe one of the most overwhelming things about being in data and technology, is just the noise of how many tools and platforms are on there, from something that's supposed to help with machine intelligence to logging, going through logs like Splunk. There's for sure some of these that'll bubble up more than others, some more popular in certain geographies, but some are open source and some are proprietary. We have to buy licenses. Some are cloud native and some are not. This is where we can help. I can just, I could probably pick 20 tools on here that 80-20 rule that we see 80% of the time. And so if you're doing evaluations, or you want a short list of things to go pilot or do proof of concepts on, let me know, because man, sifting through this is a nightmare, and I hope you don't have to do it individually. I hope we, or somebody else on the line here, if you want to talk to a peer organization, maybe they can help guide you based on their experience. Let's double back for a second. I got one more concept I want to talk about, which is something called Lambda architecture. So this data integration part right here, let me see if you can see my mouse. So this part, or data integration, we've got a couple of ways to go after that data, and you're going to hear this terminology. So I really thought that I should make it clear as to what I'm talking about. Batch processing versus stream processing. That's the term that you should go Google, is lambda architecture, like the Greek letter. And this is nothing new, but this is just a way to decide what kind of timeliness and methodology you should use for going and getting new data. Really, do I schedule something to go get data, or do I, implement triggers and things to watch for brand new records? Really, it's the bottom two lines that are most that determine this most often, which are, do I really require real-time latency in seconds or milliseconds, or can I wait, minutes or hours for that data? Most of the time, it's good enough for me to watch for new records and maybe replicate them every hour or every couple of minutes. That doesn't need true stream real-time processing. That's a completely different set of engineering that we would need to do. But I can give you a better rubric for this if you really want to go into it. I just don't have the time to do it today, but this is a concept I want you to be comfortable with. And we talked about this last time, and it's going to drive my next poll question. But we used to do things the traditional way, just that top row, where we would extract things from our data source. Your data warehouse, I'm not going to actually influence your answer, so I won't say that. But often, data warehouses will rely on some sort of ETL pipeline. So the top row here, where we're taking data from a source in flight, we are doing something to it. We're joining tables together and doing lookups. We're turning a code into a description. We're making sure that dates are valid. And once we do all that validation, we land it in a data warehouse where the schema has already been pre-built for us, and all that transformation that we've done fits like perfect puzzle pieces into the data warehouse structure that we've already done. That takes a couple of things. That means we have to understand that schema and what that data looks like before we even go get it. And that means that if it changes over time, we've got a lot of data warehouse development to do, and sometimes that can take a long time. So the modern path that we generally take, and this is where I drew last time, and I hope it works again this time. The modern path that we take is more like this. So we are replicating data from source to our data lake, and we land it as is. Sometimes that's good enough, especially for data science and more advanced analytics. That might go out here and be used by our users just like that. Or if data needs, so maybe this is financial transactions and we've got some finance reports to build for our executives. Now we take that data, transform only what we need to, impose a schema on it, and it lands into our income statement reports, right? But this really, not imposing a schema on everything, really cuts down the time to value for most data sets. It doesn't always have to be perfect before we start working with it. Maybe I'm landing it in the data lake and saying, all right, go build a model in whatever tool you want and show us what you want for a data warehouse structure. It allows us to do rapid prototyping. So in 90% of cases, I really want you to think about doing it this way, in this order, okay? That leads me to my next poll question, which is, are you already doing this? So I'm really curious to hear if your organizations are already taking advantage of that kind of infrastructure where we're just replicating data, and maybe you as a business user have access to that raw data, or if you're dependent on something upstream from you to go organize that data for you. Oh yeah. There we go, I'll give it one more second. Vote, vote, vote. All right, cool, I'm gonna close it. All right, I think this is really interesting and probably what I would have guessed, which is almost half of you are just using ETL, so probably still kind of a legacy architecture for your ETL kind of data warehouse environment. Some of you are dabbling in it, and I'll take that to say, maybe you're not all the way there with your analytics, like modernization of that pipeline yet. And then lots are using ELT. Good for you guys. You're probably more cloud native than most other people that are on this. And if you're not sure, I can help you find out. There's some pretty easy questions to ask to help, but I think it'll drive the potential of what you're going to do with the data that's locked in there. All right, cool. Thanks for sharing that. Let's talk about how to organize these pipelines. So conceptually, pretty straightforward. We're moving data from left to right, but how do we organize all this? This is where I was saying this used to be a scripting exercise, and you used to spend your time, you know, in a console writing scripts and code. But these days, pipeline orchestration looks just like any other really friendly website. I can click on wizards that help me get started. They've got pre-built connectors for me. This is an example from our own Azure environment. They've got templates and blueprints for me to follow. They've got reference architectures where I can say, I don't know, I need a real-time data warehouse pattern, and it'll say, okay, go fill in the blanks and create your connections. So it's doing all of our error handling for us. It is, you know, doing code repository, so like version control on everything. It's pretty amazing how far it's been abstracted for us now, and this is all on the web. This is from, you know, it's pretty awesome. And that's what the cloud allows us to do, is to take these services and abstract them for everybody, right? So, you know, you're not needing client tools installed on your desktop. You know, new features being rolled out every day or week. You know, if in this case, if it's Microsoft, that if you're using Azure, maybe there's some new feature and they just include it, you know, and the next time you open it, there's a new button in there, right? So you kind of see this rapid acceleration of capabilities. And so that's what the cloud allows us to do. The licenses to manage, you know, if you want to try this out, most of the time you can do it for free up until a certain amount of data or workload that you're running. So really, really compressed time before you have an idea and you can actually test it and validate it or fail it, throw it out and double back. So that's what the cloud allows us to do when it comes to orchestration. Again, these aren't scary interfaces. This used to be pretty intimidating. If you're thinking, yeah, I already have ETL tools like Informatica or Oracle Warehouse Builder. I'm trying to think of some legacy ETL tools, but you know, and those are good platforms. They're big though. If you think about what it takes, say you wanted to do a pilot or a proof of concept with one of those big ETL platforms, you got to get somebody to provision servers for you. You need licensing. You probably got to work closely with the vendor, you know, and they're going to work out some sort of pilot deal with licensing. There's a lot of different people that have to be involved. But if you want to try out one of these cloud platforms and go build it, you could do it while I'm talking right now and go to your AWS or your Azure or IBM Cloud portal and just spin it up and start dragging and dropping and connecting. I think that's the biggest benefit, and man, the cloud has really allowed this whole analytics world to explode, just because it took so long to get some of these things started. By the time, you know, you got budget approval and whatever, like, you know, the heat had worn off and people were just tired out by the idea. Now, if you look on the left-hand side in this screenshot, for example, if I've got some query that, you know, is taking a long time for my relational database to run, I could go test it out on a Spark cluster. So I could expand that Databricks section and say, go run this on Spark. And the cloud would say, okay, provisions your Spark cluster for you, allows you to write SQL, goes and does a big calculation and gives you back the result set. And you probably did it with your free credits. And so, you know, you can kind of prove this pattern. And then if you need to go and turn this into a formal ELT or ETL pipeline, you could say, look, I kind of built it already for you guys, right? And you don't need to be a big data engineer. You guys can drag and drop, right? And so I'm trying to inspire you to get started. Some really important concepts. Now I'm going to go even a little bit deeper. This is just because I needed to pick some sort of reference architecture. This is a reference architecture for IoT, so like streaming devices. So two things I really want to focus on in this architecture. One is events and triggers, so things that are actually like triggering workflows to run. They're watching data sources for changes, and then they're kicking off other things downstream. And then our serverless functions. So we talked a little bit about serverless concepts last time. I'm going to take the computer science away this time and just talk about it in terms of data engineering. So these are two really, really cool concepts that might change the game for your architecture. events and triggers, again, we used to have to write like scripts and code to watch some sort of source database for, or buy some proprietary software as an agent to go sit and watch for new records if we wanted like near real-time data. But now that's what so this is an example from something called Logic Apps. That's what it looks like. It's when this happens, do something, then go, what are they saying? Register it in our data mart. If that works, send a message on Slack to everybody. If it doesn't work, run this stored procedure, probably going and rolling back some of the integration that was done. We've usually got two different types of triggers. So polling triggers, which is exactly what it sounds like. It's kind of regularly checking something for changes, and if a column changes or whatever, then it might go and run some sort of process. So it's polling all the time. And then we've got push triggers. So if you're taking notes, those are the two types, polling and push. Push triggers actually listen and wait for a change. And then when a specific event happens, it goes and runs a workflow. So we've got one that's kind of always watching and one that's waiting for changes, okay? The coolest part here, and we talked about, I won't go into the details of serverless again last time, but this doesn't really run on it's not running on a computer. It's a service that just kind of exists out there in the ether of the cloud in what we call a container. So a really cool little thing that allows you to watch for new records and maybe write them into your own little database so you can have a real-time dashboard, for example. When I talk about serverless, these functions, you will see, I'm going to go back to the architecture for a second just so you can see as a reminder where that is. So once an event has been detected, say a new record's been entered in our accounting system, there's a new transaction. Our event detects that and moves it along. Our serverless function takes that and does something with it. So maybe it runs a machine learning algorithm on it. Maybe it does some sort of transformation. Maybe it does a calculation, and then it pushes it downstream again. In this case, it could be writing it to a data lake, or it could be writing it to another data store, for example. So that function, here's a bunch of use cases for it, and you'll get these slides after, but these are the ways that we use serverless functions in the analytics world. So running scheduled tasks, processing data in real time, like I just explained, processing file uploads. So a lot of the time when we're landing a piece of raw data in our data lake, this serverless function will pick it up and go do something with that data. So these again are things you can build yourself. You don't need data scientists to go build this for you. And I'll give you the resources to do it. Most of the time, so they can be scripted. They can be written if you're a Python person, for example. If you have a statistics background, you could write it in JavaScript. And then there's like deeper, lower, if you could write it in C# and PowerShell. The technologies, I'll give you some things to Google. Azure Functions, so that's the Microsoft flavor. AWS, these are called Lambda functions. In Google Cloud, I think they're just called functions as well. So Google Cloud Functions. So those are the big three. That'll give you enough to go Google and really understand serverless functions. Orchestration is also a really popular in the open source community. So if you go and Google that, most of the articles that you will see will be open source related. So something like Luigi and Airflow. Airflow was actually built by Airbnb to do their pipeline orchestration, and then they open sourced it on the Apache license. So it was really cool to read about that. We call that generation 1. So they were very focused on being task driven. Generation 2, like Flight, for example, if you want to go Google something, is much more aware of the data that it is working with. So Airflow was pretty agnostic. It just was a robot. Flight is a little more context sensitive. So again, we've kind of abstracted another layer of analytics into these tools. So I don't want to go too deep, but that's really the difference between Gen 1 and Gen 2 in pipeline orchestration. And you can use open source tools to do it. Data management in general. I'm going to touch again really lightly on data lakes just because, I know we went a little deeper last time, but let's just agree again on what a data lake is supposed to be. Centralized, stores structured and unstructured and semi-structured data, so all types. And that data can be stored as is. We don't have to do anything to it. We don't have to impose a schema on it. It doesn't have to have a certain number of columns. It is what it is. It supports Lambda architecture. I mentioned that last time. Now you know what that means, streaming in real time. And it supports massive compute requirements. So it's very elastic. It can get big and it can get small, and it has to be economically viable at both ends of that scale, okay? So that's a data lake in general. What are we actually putting in a data lake? We didn't talk about this last time. 3 different types of storage when we're talking about object storage. Just remember as our raw landing zone. Object storage, so this is generally what we are using for a data lake, storing large amounts of structured or unstructured data. It's not a traditional database with rows and columns. This is our email and videos and web pages and sensor data. Generally, when we do audits of modern data stores, this is about 60% of the data we're dealing with. Most of the forecasts that we see from big cloud providers estimate that this will be about 80% of the data that we deal with in a couple of years by 2025. So there's some really good studies on where this is going. This is your data lake. In almost every architecture being built today is built on an object store. There's file storage, so you can literally think of this like a share drive on your network, but you can use the cloud. Every one of these cloud providers has a file storage capability where you could just, you've got access to it kind of in Windows Explorer, right? It just looks like another drive or file system, but it's out there on the cloud. And so you're not responsible for backing those files up, et cetera. It's, you can take advantage of all the cloud native things. And then table storage. Yes, we call this generally schema-less storage. So like NoSQL, if you're gonna Google something. This can be things like key stores in Azure. This is, I believe, wrapped under Cosmos DB as a capability, but I just want you to really think about these 3 types of storage when you're thinking, where should I land the data that I have to use? Object, file, and table storage. Man, we can go really deep on the types of data. What the concept of this that I really want you to understand is actually that second column in this table, which is columnar. So it's a brand new concept if you're used to just working with rows and columns of data. In analytics, most of the time, we don't need a million rows. All we're doing is saying, give me the sum of those million rows. And so what we can do instead is turn that data sideways. And we talk about this as a columnar data store. And so it's really good for aggregation in most of the analytic workloads that we're doing. And therefore, there's new file formats that we can use, like Parquet, for example, which is what we tend to default to. That is really good and kind of the default for data lake object storage. So if you're gonna go and Google anything, I would Google Parquet files or columnar data stores and really try and understand why you would use something like that. A lot of it has to do with the aggregation of a million rows that I talked about. And if you have everything on one row, it's really easy to compress that data on disk, and therefore it's super cheap. So we've got 2 big benefits of doing it that way. We could spend an entire session just on the data science of file compression and columnar structures, but I think you get the point. I just want to give you some things to go and research. We didn't talk about this last time, which is what does a data lake actually look like? So I took a screenshot from one of our data lake environments, and it's not scary. Look, there's our 3 zones. If you go all the way over to the right, our ingestion or raw zone, our curated zone, and our trusted zone. So those are just files in a file system, right? And we're using these tools that we've talked about to move things between those files. It's really not scary. And if you want to go see the raw data here, whether it's a CSV or a Parquet file, you can go check it out right here and query it and see what those records look like. So I want to strip away some of the scariness around data lakes. Look at it. It's a cloud file system, okay? And then with some really complex computing capabilities on top of it. We're going to talk about governance. I'm going to do this a little tongue-in-cheek because of the last slide that I have. But when I talk about these zones and moving things from left to right, you really should think about what you're trying to accomplish. Don't kill an analytics deployment with governance. I've seen it done. I've seen it done where we put so many restrictions on data that it's just almost impossible to get through the entire pipeline. So I would say rethink the way that you govern data right now. If you're automatically locking down, that store can only see that store's data, I don't know. It's time to ask the tough questions. Like, is that really the case? Is that just a tribal thing that we've done forever? that, I don't know, maybe I just like to stir the pot, but I think, you're going to get way more value out of data if you can look at the big picture of data. And so apply all of these things with some degree of restraint, because I think you could really quickly choke off the appetite for analytics in your organization. I want to talk about metadata, because if you remember on the types of data that I was talking about, from structured and unstructured and semi-structured, the last one was metadata. It's data about data. And so I want you to think about, what are we actually tracking when we track data? If we are getting a piece of data from a source, we should understand where it came from, who's responsible for it, when did we actually bring it into our environment. We should also think about who has touched, or what process has touched this data. Is it raw? Did something perform a calculation on it? Was a lookup done? So who has touched this piece of data as it's gone through our architecture and infrastructure? And I get that it's kind of dark that I'm using a crime evidence bag as my analogy here, but you have to forgive me. And then the life cycle. We don't need to keep all data around. Honestly, a lot of data is exhaust and probably doesn't have a ton of analytic value. But even if it does, sometimes we have to get rid of that data. It has to be disposed of, maybe for legal requirements or whatever. So we really should, for audit purposes, we should tag that data for when it should be, earmark it for when it should be either archived or destroyed. So all those things are really important when we're talking about data about data. Don't overlook that as a concept. Data catalogs in general are getting really advanced. They can watch a lot of that for you. So if a transaction, if a piece of data is getting touched along the way, that can be tracked by a lot of our governance tools these days. This is a screenshot from something called Azure Purview, which is pretty new. But just watching what happens on data from A to B, trying to make this less of a manual process, and not turning it into some sort of over-engineered art of data governance. I've seen so many data governance projects, I just told you, kill analytics initiatives. I know the irony of that is painful, but that's not just my opinion. You guys remember this when I showed you last time where data lakes were on this diagram, and they're kind of all by themselves in the middle? You might have noticed, but look at the two governance categories that Gartner puts on its curve. The only two things that it says are obsolete are a data catalog and analytics governance. What does that mean? I don't know. I don't think that means that they're purely obsolete. It means the way that we were trying to do it. So we're trying to take kind of generation one methodologies for data governance and applying them to this new world of data just can't be done. And so we need new ways of doing it. I kind of encourage you to get creative on the way that we govern data these days, because it is the lifeblood of competition and efficiency. We can't choke it off with the way that we were doing governance before. So I thought this was kind of funny. All right. Much like last time, I'm going to give you some homework. You guys probably hate me, but that's okay. Hopefully you come back for part 3. But I think I heard from a bunch of you. I thought it was really cool. You sent me ideas of what you had for analytics projects, asking about machine learning and advanced analytics, asking about data lakes. Send me stuff. And I literally am just sitting there replying to everybody and saying, here's some examples, sending screenshots. So please do send to me. I thought it'd be cool to share what everybody is saying. Again, don't let this end with you. If I'm doing this for a couple hundred people and you go do it for 3 or 4 people, man, we've touched a whole group of folks who could do something about analytics. I think that'd be really cool. If you want help putting this together, I'm around. Let me know, and I can share raw slides with you if you want. The one piece of homework I'm going to give you that is legit is to go read this article, and we're going to include it in the follow-up you'll get after today. It's from the Financial Times, which is a newspaper, and you can imagine the evolution that a newspaper has gone through. When they started this journey, almost all of their readers read the news in print. And then what they do is they talk about, it's really like a master class on what I just talked about, going from generation 1. They go through 5 different generations and evolutions of their pipeline. And so there'll be a lot of terminology that we talked about today that you will see in their architecture, and some will be brand new. So it might lead you Wikipedia style down a couple of rabbit holes, but I'd like you to go read that, check it out. It's a Medium article, so it's really easy to read. And then I'd like to hear your thoughts on it. I think some of what they have done looks silly in retrospect, but for sure they needed to learn their own lessons And so I thought it was really cool. You're for sure going to come back next Tuesday, right? I hope to see you then. That is when we say, okay, we've got data ready to go. Now what do we do with it? So data warehousing, BI, visualization, machine learning, and data science. I'm going to go through all of it, kind of that last mile of data next Tuesday at 2 o'clock Eastern, 12 o'clock here in Calgary, and I hope to see you then. Until then, thank you very much for all your support and input. I really appreciate it. I think everybody gains from it. And I hope to see you next Tuesday. All right. Thanks, everyone. Signing off.